Fingerman, candidate in arts.
Despite a lifetime of To test how a lifetime of education affects our understanding of science, we asked these recent graduates some simple questions in astronomy. Consider, for example, that the causes of the seasons is a topic taught in every standard curriculum.
Okay, I think the seasons happens because as the Earth travels the sun, it gets nearer to the sun, which produces warmer weather, and gets farther away, which produces colder weather, and hence the seasons.
How hot it is or how cold it is at any given time of the year has to do with the closeness of the Earth to the sun during the seasonal periods.
The Earth goes around the sun. And it gets hotter when we get closer to the sun, and it gets colder when we get farther away from the sun.
These graduates, like many of us, think of the Earth's orbit as a highly exaggerated ellipse. Even though the Earth's orbit is very nearly circular, with distance producing virtually no effect on the seasons, we carry with us the strong, incorrect belief that changing distance is responsible for the seasons.
I took physics, planetary motion, and relativity, and electromagnetism and waves.
I've never really had a scientific background whatsoever, and I got through school without having it. I've gotten very far without having it.
I had quite a bit of science in high school, yeah, through physics, first year, and 2 years of chemistry.
Regardless of their science education, 21 of the 23 randomly selected students, faculty, and alumni of Harvard University revealed misconceptions when asked to explain either the seasons or the phases of the moon.
When it's further away from the sun, then it gets colder.
The Earth's position interferes with the reflection of the sun against the moon.
Class of 1924. The class of 1925.
To test how standard instruction succeeds or fails in reversing such misconceptions, we interviewed 9th grade students from a nearby high school. The students selected had little training in astronomy.
When it's winter, it's when the sun is furthest away from the Earth, and when it's summer, it's when the sun's closer to the Earth.
Why is it hotter, say, in the summer than the winter?
It's hotter in the summer because we're closer to the sun than we are in the winter.
Tell me about the different shapes of the moon.
Of the moon? When the sun's right here, the Earth blocks the sun rays, and it causes the moon to have a shadow right here. So
that the monthly cycle of lunar phases is caused by the shadow of the Earth is another popular misconception.
Can you difference in seasons? What's different about different seasons of the year?
In the summertime, it's like we're closer to the sun, and the sun's rays are coming down, so it's hot. And in the winter, you move further away, I guess, and it gets colder.
Unlike the Harvard graduates, these students have had virtually no instruction in science.
And does the moon have different shapes? Or?
No, it's round.
It's round. Does it ever look different than round?
Yeah, it does. It looks like a half crescent. Can look like a half.
Mm-hmm. And what causes that?
Clouds blocking it. Like say you had a half moon. This is here with clouds, and all you see is the half moon.
Like a scientist in search of an explanation, this student created his own unique theory to explain the phases.
I don't know. I don't know what you got some kind of can of worms here as to why kids don't understand it all.
If we went outside today and out in the grass there, we'd see the sun up above.
Mm-hmm.
What would things look like, say at 8 o'clock?
At 8 o'clock, the sun would have the Earth would have rotated so that the sun would be on the other side of the Earth, so then it would be dark here and we'd be able to see the other stars, yeah.
Okay, and where would the stars be in the daytime?
They're still out there, we just can't see them, because it's not dark enough.
Heather's very bright. On a scale of 1 to 10, maybe, I would probably put her at the 9, a little bit above the level of the other kids. And I would expect her to know the answers to these things.
That's the sun, although it's a lot bigger.
And then there's a planet and another planet, and then there's the Earth, because it's the third planet up from the sun. And then there are 6 more planets. And, okay, the Earth revolves around the sun. The moon revolves around the Earth. So this goes like this, and that goes like that. And each time the Earth goes like this is a day. And it takes 365 days for the Earth to go all the way around the sun, and that's a year.
You may recognize Heather as typical of your best student.
Yeah, I would expect that can give a better explanation than the other kids could. I think she has a little bit, and she's a lot more sure of herself. The other kids, I think, might have been a little bit inhibited and were afraid. And I hope she'll tell you what she knows.
But the Earth doesn't quite go in a circle. It's more of, let's see, it's more like sort of like that, I think.
On probing, we see that Heather believes that the Earth travels in a bizarre curlicue orbit.
And when it's farther away, it's summer. When it's closer right here, it's winter. Okay, it's winter when it's closer, and it's summer when it's farther away because of, well, at least for us it is. Because of this axis. When the sun's rays are indirect, it's summer, because we get warmer. When the Earth is closer, the sunbeams are direct and it's colder.
Could you draw a picture of what you mean by direct and indirect?
Okay. When the light comes from the sun, when it's direct, it comes straight from the sun to the Earth, I think. And when the light's indirect, it sort of bounces off and then comes to the northern hemisphere. It's different.
Heather believes that light can bounce, and that this somehow causes the seasons.
When it bounces off and then when it sort of, well, when it doesn't go in a straight line, I guess, it's warmer. It's confusing.
What about the moon? What does the moon look like?
Oh, this is mind-boggling, though.
The moon has like 4 cycles. And so sometimes it's full, sometimes you can only see part of it. Sometimes we just can't see it at all, and other times you can only see this part of it. That's how come it sometimes looks like a sickle.
Could you draw me a picture of how that happens?
Well, if this is us over here, then we can see the moon, and the rays from the sun sort of come around, and they only illuminate part of the moon, because I guess it's the Earth's shadow or something.
Heather's private theories contradict the teachings of even the most elementary science courses.
You assume that they know certain things, and even the day that I taught it, I come in and I just assume that they had the basic ideas, and they don't.
Heather's teacher was unaware of the students' private theories as she taught them their first formal lesson in astronomy.
Going through changes. Are we the only ones that have changes? You ever hear that about the moon, the phases of the moon? What does that mean, Jean? The phases of the moon.
Stages.
It goes through different stages?
Something blocks like clouds.
Oh, something blocks it?
Yeah, it's like clouds
You
block
can
it.
explain all that to me. Clouds block it? You mean when there are no clouds, then it's always full? How about when it's like this? Can you see that?
No.
Now, where are we?
On the dark side.
We're here. So when I look up into the sky, what do I see?
Nothing.
Nothing. You're not going to see anything. The moon is still there, but there's no light being shown on that side that I can see. Could anybody show? James, do you want to show us? You were showing us earlier?
Yeah, what?
Could you explain to me why the moon has phases and why we see, different things at different times? Can everybody see? John, you have a question?
Oh, like a half moon, full moon.
A quarter of a half moon is the crescent?
Well,
why is it called a crescent?
it's shaped like a crescent.
It's curved. It's shaped like, those crescent rolls, right? No, not cross. Well, yeah, actually, I suppose it's all the same word. Okay, James, thanks. Okay, does the moon have any light of its own?
No.
Where does it get its light?
It gets light from the rays that bounce off the sun.
What's another word for bounce off?
Reflect.
Reflect, okay.
Like if you're on the moon, you could see the lights bouncing off the Earth.
Okay.
Yeah, there's America, and it's nighttime right now. And you'd see a half moon right now, because the sun, the way the moon's facing the sun. shaped like that.
So the moon doesn't actually change shape.
No, it just the way the sun hits it.
Does everybody understand that? John Dixon, did you get that?
Yep.
Everybody see that?
We interviewed Heather again 2 weeks after the lesson to see how her private theories were modified by teaching.
What I got confused about was, if the sun's here, what does the path look like when, that the Earth takes? And I wasn't sure whether it sort of went like this, or, whoops. But then we figured out that it sort of went like that.
I'm surprised that she remembered the exact picture she had drawn. I mean, she didn't even hesitate. It was like, right, like this. And when we saw it originally, to me, it seemed like such a crazy... I mean, that really was her idea of it. It wasn't just, well, maybe it'll be like this. I mean, that really was her idea of how it orbited.
The first idea you had about this curlicues, where did you get that idea?
I have no idea. It was probably because I was looking in my Earth Science book in 8th grade, and I looked at another chart and got it confused with this one.
In class, Heather was able to reverse the misconceptions she had pieced together on her own from books and other sources.
So, this one's wrong.
But just as often, misconceptions can originate in the classroom. For example, the notion that the seasons are caused by the highly elliptical orbit of the Earth is a misconception which results from perspective drawings found in many textbooks. Let's see how instruction has altered Heather's other theories, such as the one she holds about the phases of the moon.
And then here's the Earth. And the moon's turning around it in intricate little circles. So as the moon goes around the Earth, at different points in time, the sun illuminates different parts of the moon. And as it goes around, people on Earth can see different phases of the moon. The full moon, the crescent moon, the new moon.
Heather appears able to recreate the teacher's explanation perfectly.
What did you learn in class, and what did you know on your own?
In the 9th grade class, when you came to videotape?
That's right.
Well, we learned the phases of the moon, although we didn't learn where the moon was at those times. Because I don't remember learning that. So that makes it sort of hard because you know what the phases are, but you don't know where the moon was. I mean, the moon could be over here, it 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 could be, practically anywhere on its orbit around.
But she still has some lingering doubts, and when pressed, shows that she still holds on to her private theory about the shadow of the Earth.
I'm almost sure that a lunar eclipse is when the shadow of the Earth is over the moon so we can't see it. But I'm not sure about the new moon and the full moon. Whether it's, whether it's that it's because the moon's right in front of the sun so that the back's getting the light and we can't see the light, or whether it's because over here, over here's the new moon because of the shadow. But I think it's over here's the full moon. Yeah, that would make sense, because if it was just, I think over here and over here, no. Over here's the full moon, and over here's the new moon. I'm almost positive about that. Almost, haha.
When did you come to understand that?
Well, if this was the new moon, then a lunar eclipse would be so special, because that would mean that the shadow would would once a month be shutting out the light of the moon, or the light that bounce off to the moon. And so then a lunar eclipse wouldn't be so special anymore. It wouldn't be a big thing. It would just be a lunar, it would be called a new moon.
If Heather hadn't been forced to confront her private theory, she might never have learned the correct explanation.
But I also know that what happened was that she had to hold the things in her hands. I mean, you didn't even, whoever was filming her, didn't say, use these to show it. They said, how did that happen? And she immediately took them and started working with them and figuring it out. And I think too often that doesn't happen with kids, that they don't get to see it exactly in their hands and feel it.
We then asked Heather about the seasons and her theory of bouncing light.
Because the Earth is tilted and the sun is right here, this would be, let's see, this is the northern hemisphere, so then we would be having summer. Like the rays would go like that, and down here they would have winter. And on the equator it would be summer because it's summer all year long because they get pretty much direct rays. But when, let's see, when it's over here, because this part of the Earth is showing towards the sun, that gets the direct rays, and that means they're having summer down here and winter up here.
Again, Heather gave a perfectly acceptable explanation for the seasons. But then, we asked her to define the terms direct and indirect.
Direct rays are rays coming directly from the sun. Indirect rays are when they come from the sun and then bounce off another object.
She does not let go of her theory of bouncing light.
Sort of like if they bounced off a mirror. If you had a light bulb here, a mirror here, and if you twisted a light bulb so it was like that, light would bounce off the mirror somewhere else. And so if you had a mirror here and a light here, the light would bounce. In winter, I guess because it would sort of bounce or something.
I don't know where she picked that up. Somewhere along the line she did, and she just doesn't want to let go of it.
Since Heather's misconceptions were not directly addressed in the class lesson, we tried to alter her inappropriate definition of direct and indirect light through one-on-one instruction. Notice how she tries to blend these new concepts into her old.
Earth is here, and the sun's rays are going directly to the northern hemisphere. That would be summer, because the rays would be stronger, both because they weren't getting interrupted for anything and because the rays of the sun would be closer together, like shown right here. And when the northern hemisphere is farther away, it would be winter up here because the rays from the sun would be hitting at a slant and it would sort of bounce off other parts of the Earth.
Her own personal theory is so deeply ingrained that despite our attempts, she never abandons it.
I guess you have to realize that kids really do have the ideas coming in, and you think that it's like a void, but it's not. They have experiences and they have ideas that they associate with other things. And until you kind of straightened out those initial ideas, it kind of closes off their minds to what it is you're trying to get across to them, really.
That's 23.5 degrees. That's the angle of the tilt. It's not that much. It's not that much, but it's enough to give us the 4 seasons.
Every time we communicate, new concepts compete with the preconceived ideas of our listeners. All students hold these ideas, but they are unaware of their private theories.
The ocean under the moon has... As it spins the sun, the spot on the Earth where the sun moves.
Do you think we are in terms of the rotation that we make?
We must make them aware. Only then can we enable them to learn and free them from this private universe.
For information on this program and others in the Annenberg CPB collection, call 1-800-LEARNER.